Good morning, guys, and welcome to System Engineering for the morning of 4:20. What we're going to be looking at today is we're going to be thinking about our systems projects in a much more logical sense so that we can help decide what components we need for our projects. So one of the things that I get people to think about is turning their whole project into a series of flowcharts and boxes. All right, and the reason why that's important is that it allows us to conceptualize our project as something other than what it is, and it helps us break it down a little bit further. So if I have my pen here, the goal will be to say, if I think about a toaster, and I have my input, I have something that happens in the middle here, and I have an output, and then I have something that goes in here. And then down here is my waste. So in the case of a toaster, can I get some suggestions in chat for what the input, the output, the waste, and the process might be for a toaster? Yeah, okay, so input. Okay, so I've got two very different types of answers. Both are correct. All right, so the input, yep, bread. No, Lockie, you said energy. Energy, yes, I know. So bread goes in. What's the waste? What comes out? What's the waste in a toaster? What comes out? Mm-hmm. All right. So what happens inside? What is happening inside our toaster? What process is it undergoing? Yep, so it's being heated. All right, so we also have to remember that not only did bread go in, electricity also went in. So bread and electricity go in, heat, output is toast, waste is the crumbs. There's also one other waste product. What is the other waste product when we are making toast? So I would say there would be something like maybe the excess heat, but there's also one other very, very, very bright thing. Thank you, Divana. and then we have our light. Of our light. So what that means is that we have a process that's undergoing here, and then we have our waste products that come out of it. So let's try let's see if we can't conceptualize that in another way. Move down here. And let's try something a little bit more involved. Anyone want to help me out and select something? Something you might find around your kitchen. Oven is basically just a big toaster. Alright, microwave is interesting because microwave has a couple of extra components inside it as opposed to a toaster. So a microwave has our inputs, it has the process, and it has outputs. But inside a microwave, how many different processes are there being undertaken? When you think about a microwave, what is actually happening inside the microwave? I would say light is one of the products, whether that's a waste or not. That's merely, do we need the light? We don't need the light. All right, the microwaves allow it to be heated, which is one of the things that we want. But there's another more mechanical process that takes place inside a microwave. How do we ensure that what we're microwaving heats evenly? Spinning the disc. Yeah, so it turns. So we've got the process of our microwaves being generated. And then we've got the plate rotated. So what are our inputs? Food, outputs, cooked food, electricity goes in, if you are not watching full screen, you will not see the whole thing. That's just because it's WebEx, and WebEx is WebEx. but I'll move that over for you. We have a couple of other outputs. So there's the excess light energy, or there's the excess heat. There's the light. Some things aren't useful, some things are. Alright, one of the important things that you guys need to think about in your folios, in part of your projects, are what things I want you to think about is what parts of my project, what goes into my project, what comes out of my project, and then the processes that you want to have happen to it to get it from one point to the other. Alright? So what inputs do you need it to be given? What output, what's the desired output at the end? So in the case of your projects, or what I want you to do today, is that I want you to try and break down your project into the different IPO, and we need you to create, I want you to try and create an IPO diagram. Alright, so an IPO diagram. Alright, there are some websites that allow you to easily make them. Yes, in your own books of our own project. All right. Now there's an extra level that goes above these things. All right. There's an extra level that goes above the I, the P, and the O, and that has to do with how do we control this. All right. So it's especially important when you think about it in terms of things that are automatic. All right. So if we try and if we look at a different type of thing, so let's look at so I know where I'm not allowed to go. If we think about our houses, we have air conditioning, we have heating in those. But how do we control our temperature? How do we control the temperature in our apartments or our houses or whatever? So if we have AC / heater, now we don't need to talk about literally how it does this, but if we think about what we want, input, process, output. But what do we have that sits over the top of all of this in terms of control? All right. How is it being controlled? How is everything that's going on being controlled? What controls a different input system? So if I go in and I go to the thermostat on my air conditioner, I set it to a temperature, but it doesn't automatically become that temperature, does it? What has to happen in the first place? What is happening inside my air conditioner so that it keeps repeating itself or repeats a process until we get the desired outcome? All right, so this is where things such as loops come into effect. The input would be the desired temperature. The output is the required temperature. But through this whole process, there is something that sits over the top of it all and controls it. All right? The thermostat inside the air conditioner or the heater controls this whole process. All right, and what happens is you input your desired temperature, the required either heating or cooling takes place. And then what happens is it checks the temperature. It checks the temperature and then decides, well, if it doesn't match my desired, repeat. All right? So what it does is it takes your diagram, it takes the process and repeats the process until we get over here. So if the temperature equals the desired temperature, then will it keep going? Alright, so if the temperature is the desired, stop, otherwise repeat. Alright, so it'll keep doing what it's required until it gets to that desired temperature. And then it will constantly check in the background that, oh, say something external to the thermostat or something external to the air conditioner has happened, and it's caused the room to heat up again. I don't know, maybe the sun's come out of the clouds or something and it's heated the room up. The thermostat will then turn it back on to bring the temperature down. All right. So what's going on here is that this system is always working in the background, as long as you've got it turned on, as long as there's power going into it. The process will keep going. All right. So what I want you guys to do now in your books is I want you to really think about what project you're working on, what the inputs and the outputs and the processes are going to need to be for your projects to be successful. All right?